So I want to show you how you can actually create a private blockchain network and how you can deploy a contract to it and then use it from an application that you can build. I'm not completely sure yet how I'm going to do it, because doing demo and holding the microphone is going to be some challenge, but we will find out how that will work. So basically what I will try to show you is a server machine running Ethereum, and that can be one or more nodes talking to each other, and then creating a private chain on that node, and then from the client side, so the development side, how you can deploy a contract, and I'm talking about a smart contract, as Mike just explained all about to you, how you can deploy it to the chain and then how you can use it. And you can do that either using command line tools, or if you would like, you can also use some, of course, some editors, like we have Visual Studio Code or other editors, but that's all up to you. So first I want to take you to the site to set up that machine, and that means that I'm going to show you probably a little bigger. Can you read this, or should it be bigger? Is it okay to read? So what I have here is I have an Azure environment, which this is the portal, and the portal is there to interactively create and manage resources, services running in our Azure cloud. And I already created, as you can see, different blockchain environments, but I will just go and create one from scratch so you can actually see what I'm doing. And then I will go to one that I created already, and we can have a look at that. So let's say that I would like to create a virtual machine running a private network. I would go to create a virtual machine, and on that virtual machine, of course, an operating system is running, and I will choose now to run Ubuntu. And when you create a machine, you have to give it a name, as well as you have to supply information about who will be able to access that machine. So I'll give it a name here. This name has to be a unique name. I typically start all my tests with the first 4 letters of my last name. So, and somehow that's also possible. That's always possible. I don't know why. Nobody seems to use the word hack. I have to give it a password. I have to do this with 2 hands. Okay, so then the next thing to do is to choose how big of the resources are that I will use for my virtual machine. So how will it run, with how many CPU, how many disk, what type of disk, and of course this really, what you choose here, there's a really a big difference in the price that it will actually cost you to run this. So I will do a not too complex one that is not too expensive. So I will choose this one with 1 core and some disk. But of course you can choose a bigger one if you want. And then what it will do is it will create a virtual network for me, as you can see here, and also it will create a public IP address for me. So, and I need, of course, the virtual network is there because if I need or want more than one node, which I probably want in my setup, they need to be able to talk to each other. So that's why I need a virtual network. And of course, I need a public IP address if I want to be able to talk to this machine from the outside world. And for now, I do want to talk directly to this machine from the outside world. I will show you later how you could think about a global architecture, and maybe at that point you don't want the blockchain network nodes to be accessible from the outside world directly, but for now I want that, so I also have a public IP address. So what I can do now, and I can immediately select which blockchain artifacts I want to be installed on this virtual machine. But unfortunately, we just found out that when you use one of the free Azure passes, this functionality is not currently available. This is very new. We're trying to find out right now why that's not available if you have one of the Azure passes. Of course, you can still do this manually and install it on your virtual machine, but we will give you some information on that. For now, I will select to install the Ethereum on it, and it's here. And I have to supply the name that I used as an administrator name for the environment to be able to install everything correctly on the virtual machine. So I'll add this. And what will happen now is that a virtual machine will be created running Ubuntu and already having Ethereum ready to work with installed on that virtual machine. So that's what will happen. What you can also see, because I am now using the now using the portal, but of course you can also script all of this. And if you want to see a sample of a template, you can see here that the portal already creates for you a sample of a template of how to script all of this to make this repeatable and to easily be able to recreate this without using this Azure portal. So I'm just going to create it, and it will now create the machine, and we can access it later when it's created. It will take, I think, around 5 minutes or so to create the machine. So I already have virtual machines created, as you can see here. So I will just go and connect now to one of the machines that is already there. And to be able to connect to it, I need the public IP address or the DNS name. But I'll just go and copy the public IP address. And then I can use any SSH client that you want to use to connect. And in my case, I am using PuTTY, but it's up to you what you want to use. And I can just add a connection to this machine. So maybe it's not very clear to see this, but I have to log in now. So I will use my the name that I created as an admin user, and of course I have to give it a password. And now I'm connected to the node. And if we look at what is available on the node by default, because I have this installed with all the artifacts on it, it's a little hard to read, but you can see that there are a couple of files here available. You can see a labseed.json file, and there are a couple of sh files like seed to blockchain, start to blockchain. So these are some helper files that are available for you to quickly start creating and using a private blockchain. So what the labseed.json is, it's a Genesis file. And a Genesis file is basically the first block in your chain. Because, of course, every chain has to start somewhere. And this is the only block that has no reference to another block in the chain. So that's why it's called the Genesis file. And you always need a Genesis file, and in the Genesis file you will find information like that. For example, that nouns that you heard Mike talk about. So there is some information in it that basically identifies some characteristics of your blockchain, of your private chain. And what it will do if you run this, it will create its own data directory on this machine, and in that data directory it will start your chain. That means that you can also have more than one private network running on the same node. So if you would create a different data directory and then basically start a new blockchain in that one, based on a Genesis file again, you would have different chains running within the same node. So you can have one node running more than one a chain, and to be able to access a specific a chain, you will also give it a network ID. So that's also important. You will see, if you look into these files, that in the start blockchain file there is actually a network ID, and you can give it any ID except from 0, because 0 is the value of the network that is the public network. So if you want to connect to the public Ethereum network, you can use 0, otherwise use another number. So that means that right now we could do something as to start a blockchain and do things like that. I already did it on this machine, and it created by default a data directory called chains dev test. So that's the place where my blockchain is running. And of course we can see that if we want. So we can try to look at what is available on the machine. And you can see that there is, probably you can't see, but that there is a folder changes, and in that there is dev test, and that's my blockchain. So what can I do? What can I do with that? I can access this. This chain, and then I can use the basically the programming language to work with all kinds of things that are available on Ethereum, like accounts, like sending transactions, like deploying smart contracts, or getting access to smart contracts. So you can do a lot of things at that point with your chain. So what you can also do is you can make your local machine also a node in the network if you want. So in my case, I also installed Geth, which is the client tooling for the client environment for Ethereum. I installed it on my local machine, so also my local machine participates in the chain, and I can also access everything in the chain from my local machine. This is, I think, a little bit better readable. So you can see that I started a connection to the chain over here. It's on a specific network ID, network 44, and I also added the console keyword, which means that I immediately get a connection and a console where I can do things. So, for example, I can check out here if there are any accounts. And as you can see, there are 2 accounts, and I can see the addresses of the account. So that's the unique identifier of an account on my blockchain. I can also, for example, find out if these accounts have any ether. So if there's any balance, any coin to work with, so I can actually do something, send transactions, and work with, or do transactions on the chain, because I need ether for that. How do you get ether? Well, of course you can buy it, but since we are in a private network, what I can do is I can just have a node start mining. And as soon as you start mining, you will generate value. And that value is being added to an account. So once you create value in that account, you can then transfer funds to other accounts in your chain if you want. So you're basically now, because this is a private network, I'm basically just simply creating my own Ether, and then I can distribute that to different accounts so I can actually work with it and use smart contracts and send transactions. So of course, if this was the public network, I could not just simply start creating my own Ether. I have to really burn my Ether or I buy it. So that's a little different. But in a private network, you can do just simply this. So let's say that I have a contract, and I want to show you the contract. Here it's a simple, it's a very simple contract. It's the contract that is kind of like the hello world of the blockchain, the simple storage. Also, if you go to the Solidity browser, which you have seen, there's also this sample simple contract, which is called the simple storage. And what you can do is just send it. Yes, I can. Sorry. Wait, I'll just. Yeah, sorry, yeah, but okay. It's kind of difficult to do it this way. No, but I can do it. Yeah, let's just do this. Yeah. Is it better like this? So can you read it like this? Yeah? Or okay, let me try to make it even bigger. I don't think we need that one. Oh, sorry. Where was my zoom? Sorry. Zoom in. Zoom in. So, okay. Yeah? Okay. Thank you. Sorry. Thank you for saying that. So basically, the contract is really simple. And when you have a contract, you need to compile it. And I think Mike showed this in the Solidity browser. Did he show you the part in the Solidity browser? No? Okay. So I will show you. The Solidity browser is basically an online contract development and compilation tool. So that's what the Solidity browser is. And let me go there. So this is really challenging like this. Where's my Solidity browser? Okay, see. Where is it? I don't think this is the correct one. No. What is it? Something like Solidity. Well, it's here. So let's just find it. Okay. This is it. Okay. Is this big enough to read like this? Okay. So what you can see here is that in this Solidity browser, you can just create contracts. You can start writing contracts here. So I can define a contract, and then it will immediately try to compile it. And if it is correct, so I have to always give my contract a name. If it is correct, you can find a couple of things here. You find the interface, and you find the basically the compiled code, so the Web3 deploy. So these two things you need to be able to deploy and use a contract. So when you have this information, the first thing you have to do is you will run this against your chain, and that will send over basically the deployed contract code to your chain, and will add it to your chain as something that's available there as a contract, and you will get back an address. So it will mine your contract and you get back an address, and with that address you can then reference the contract after it's being deployed to the chain. So the steps to take is if you have your deployed contract, you can just copy it here and then start using it. And what you can see here is that simple contract, and this is the interface. So this is the application binary interface, the ABI, and this is the basically the deployed contract that is being used to send it to the chain. And the way to send it is just simply by copying it and just adding it in your console. And if you do that, you get an error, which is totally correct, because now I get the error. Probably this is also a little too small to read, but I can easily make this a little bigger. So maybe something like this. Is this okay? So there is an error now saying that the account is locked. And what that means is that because what it's trying to do now, it's sending this to the chain and it's trying to get it mined. But before you can get something mined, when you get something mined, you need to pay for it. And when you pay for it, it means that it's going to get balance from a certain account. And because this is like my wallet, I first have to unlock it. So I have to give my personal passphrase, my personal password, because with that, it will unlock my private key and or my key file, which contains my private key. And with that, it can actually go and say, yes, I will get the Ether from your balance, and then that will be used in the chain to mine the contract. So that's why it gives me this error now that the account is locked and undefined. It basically says, which account should I use? And please unlock it so that I can get the Ether from it and send that to the chain. I will do two things now. I will set my default account and I will unlock the account, and then as the third thing I will resend the contract. So that's what I will do. Thank you. Okay, so what it did now, it created a transaction, as you can see here. So it did send it now over to the chain. It's created a transaction, and it will now try to mine it. And when it succeeds in that, it will give us back a message, contract mined, with an address. And that address is what we need to actually go and use this contract. Because of course you will only basically deploy the contract once to the chains, unless you really want to have different instances, but then they are totally separate uses, because they will have different versions. There will be different contracts for the chains. So when this succeeds, you get back an address which is something like looks something like this. And then if you want to use this, what you have to do is you basically have to define what is the interface. So what is the ABI? Then you have to know what is the address, and then you can create a reference to the contract, sending it, saying, okay, give me a reference to a contract that has this interface and lives at that address or is identified by that address. And once you have that, if it's successful, after that you can use all the operations that are on the contract. Because the smart contract is data and operations, so from that point on you can use data and operations that are available on the contract, just like programming against an object. So it can have arrays, it can have operations, it can have just simple fields with data. You can send parameters, you can get return values, all those kind of things. So that's the Solidity language, basically, that you use there to define it. So so this is the way that you can use a contract, and you will always do this, no matter whether you use the console or use another environment to write your application. You will always go for this information, and then you can use the contract. So that means that, for example, another thing that you could do, and let me also enlarge this a little bit. So probably, I hope this works this way. So for example, this is just another example to show you basically the same, how it works. What is used here is Ethereum, which is a set of .NET libraries that you can use to build applications that use smart contracts and work with not only smart contracts, but also just work with the Ethereum network. And in this case, if you want to use something with a contract, you basically do the same. You define what is the interface. You need to have the address of the contract. And then what it's doing, it will establish a connection to the private network. And that is actually done here. So you establish a connection to the private network, and you can give it as a parameter the address, so the public address where you can actually reach to this network. And then once you have done this, you basically again create, say, hey, give me an instance of that contract, and if you have it, you can work with it, and you can use all the operations and data again that is in the network. So it's doing basically the same. So that's what you need to do when you want to work with a smart contract. You need to have a server that is running a private network. One of the options is Ethereum. Of course, there are more options, but it works really well with Ethereum. Once you have a server up and running, running your Ethereum network, you can deploy your contract that you created to that network. And after you have deployed your contract, you can use the ABI and the address to get a connection, to get a connection to an instant, to basically that contract on the chain, and then start working with it. And of course, you can then send transactions and run against your contract. So, if you want to know more in detail how to do this, we did create some write-up on how to set this up, and we will of course share it with you. We put it on the Slack that was already mentioned, but also if you want to get it otherwise, just let us know, and we will make sure you can get the information. And of course, we can help you out to do this once you are working with this stuff. So what I already said is what I kind of showed you is this simple scenario, but you can imagine that that you need a little more than maybe that to make an application. And I guess what is relevant is that if you understand that if you have some network running, and it's running in a virtual network, and the different nodes run in a virtual network. And what I have done now was I added a public IP address on these nodes. So that means you would go directly from anywhere to those nodes, which is fine if you are doing a simple test or, you know, a proof of concept. But to be able for these nodes to talk to each other, you need to open some RPC port. And so they have to be able to talk to each other. So you have to open some ports. So that could mean that if you have this open to like the outside world, people could maybe get to your machines in a way that you don't want that to. So it's probably a better idea to have another virtual machine maybe running in your network that runs a service that will actually talk to the chain for you, and that will send transactions to using the smart contracts, will send the transactions. And don't have like public IP addresses on these machines, but only like internal. And then of course you could have a public IP address on this one, and this can be accessed from the outside world. Also, it's important, Mike already told you, to understand that a smart contract cannot by itself, yes, you can put in code in a smart contract, but you cannot in that code reach out to other services or reach out to something outside of the blockchain. And maybe that's also a good idea, because for safety, but so you can only send like transactions to the blockchain. So this application could also be the place where you would maybe go out to other services that you need to do verification or to get functionality, and then that service will then send a transaction to your chain using your smart contract. So that would probably be typically the way you set this up. And then of course, whatever you use here, well, you can use everything. You can put another Linux machine here, or you can put a Windows machine. It doesn't really matter what this is, as long as you, because at the end, as you have seen, you can use different ways to actually get to your chain and to your contracts, and it's just simply a certain pattern implemented in different languages and environments to use. This is just a reference to some links to where you can actually find the different tools. So the Solidity browser, the libraries, Geth, which is basically the client tool for Ethereum. So this is what you need also. This specific link points to the Geth library to put on your Windows machine. But if you just go to like this, download, you will find all different platforms, and also there you would find the tools you need if you want to set up the Ethereum network by yourself on a virtual machine. So if you just want to start with creating any kind of a virtual machine without using those specific blockchain as a service artifacts, you can also, of course, set up Ethereum on that using those Geth tooling. So and at the end, then you will have the same situation how it works. So any questions on this point? Yes. Okay, so what's the point in using the private blockchain and not the testnet? I guess the testnet is still public. So if you want to do something, if you want to test out things, if you want to create smart contracts, because you are working with a consortium or with a chain of companies working together, and they don't want to go public with that yet, it would be a good idea to put it on a private chain. So that's basically a reason. Another one, of course, is that maybe also that company or the number of companies that want to participate in a specific blockchain don't want to make it public. So then you would always have, well, it's private for X number of companies and people, but you know, we would still, it's still kind of a private network. So, but the first one is really the most important one. As long as you're developing, and also it doesn't really cost you anything because you can just generate your own Ether and work with that. So, yeah, that's also on testnet, that's true. But I guess the public part is the most important one. Other question? Oh, what is used on there? Yes, it's classic Ethereum. There's nothing special. There's nothing Microsofty or anything about that. The only thing that we did is we created some templates and for you to make it easy to install and run this on our cloud platform. But at the end, it's just Ubuntu. It's in my case, it's just Ethereum. It's just so there is nothing special about it. So you can also run this in your private data center or wherever. It doesn't really matter. It would be the same thing. Yeah. Other questions? Yeah. Okay, so okay, good question. So the question is, what does that network ID mean? Because I used 44 or, well, yeah, magic number. It's an arbitrary number. It's just that if you want nodes to be able or to participate in your network, they need to know the ID. And you basically, because there's some other things. You can, when you start your network, you can also say, is this discoverable or not? So would this network be discoverable for others? Yes or no? So you can say, no, it's not discoverable. Yes, it is discoverable. And then, of course, if it is not discoverable, people should really know the ID to be able to participate in a network. And you basically control then what is that ID, and you give it to others to be able to participate in your blockchain, in your Ethereum network and using that blockchain. If it is discoverable, it could mean that you suddenly be part of another network if it all had the same like ID, because, you know, it is like a big public thing, and that would mean that you would be mining transactions from other chains and other, yeah, it would then basically be the same network, you could say, but from other like chains and things like that. So it's just the identification. This is the network I want to participate in as a node.
Next question. You saw the null, 0 is a public network, yes? And what is format of Genesis file?
Okay, so what is the format of the Genesis file? Yeah, 0 is the public network, yeah. And what is the format of the Genesis file? I can show you one if you want. It is, let me see. Here you see a sample of a Genesis file. Is it readable? So there are a couple of things that are relevant here. The nouns that was already mentioned, that this is, so typically by default it says 42, but you can just change this to if you want, to another number, because that's used to to creating those sorry, The proof of work part, that's where the nouns is used. The difficulty is relevant because it kind of says something about the price that it will, it's used to calculate the price that it will cost to mine something on your network. Yeah, the gas, exactly. So when this is a lower number, this is a low number, so it is relatively cheap to do it because this is just for me it's just a private test network, and I don't want to be it to be necessary to have a lot of Ether already to be doing something. So that one is relevant. So allocation is some way to pre-populate some accounts with Ether. So you could put in some accounts here and give it them already some like pre-sales type of thing, you know, like pre-populate with some Ether. Sorry. The Coinbase, that is basically, that is empty now, but so this is empty, an empty address. But this is what you will always need to set as some account will be the receiver of all the funds when this network starts mining, when this chain starts mining. Yeah, exactly. It's the beneficiary of all the revenue, basically, from the mining. This is the parent block in the chain, which in this case is 0 because this is the genesis block, so there is no parent. This is the only block that doesn't have a parent block. This is, as you can see, just, you know, some arbitrary description, and the gas limit is basically the max amount. So there are a couple of things. It's very well described what this means, but this is basically what is in here. This is what a Genesis file looks like. Yeah. Okay. Yeah.
What is the address of maybe the network when you initialize the instance of the Ethereum Web3 client?
So what is the? You mean like if you just do it without setting anything? Okay, so what you give it there is basically the IP address where the network is reachable. Yeah. Oh, how do you set them initially, you mean? Like how do you determine? Yeah, and some port, 8045. That's the default, yeah. But you can change that because when you start the network, you can set the port. So it's parameters when you set the network, and then after that, it will be listening on some port. Yes, correct. The question was, or the remark was, that you have to set the ports, the RPC ports, to be able to connect. Yeah. Yes. So you weren't able. Okay. So you were trying to connect to your own network using the Web3, and you were not able to, even not setting the ports. And did you try just to initialize a connection using get from the command line? Does that work? Mm-hmm. Okay. So the remark here is, so for those who don't know, you use get basically to start the network or to start a connecting to the network. And what you can do is if you want on a single node, you want to have more than one connection to the same network, you can use get attach, which basically means attach this console or this to the same network. If you run get attach without anything, it will try to connect to the default network. So whatever is in the .ethereum folder, or what is there. If you want to connect to your specific, I don't know how you set it up, but if you want to connect to your specific network, you have to give the reference to the IPC, for example, in the data folder that you have used to set up your chain. I don't know, maybe it's something like that, but we can have a look at it and see what's going on. But it might be something like that. So that when you start your private network, you basically create your chain in a specific data folder, and with all other kind of things, you still, each time you really have to connect to, I need the chain or I want to connect to that specific one in that data folder on the node. So it's the combination of that one and the network ID. So it's, but we can have a look at it and see, maybe it's something like that or something else. Yeah, okay, perfect. You know to find me. Yeah. Other questions? Other questions? Sorry, yeah.
Security level, if I start a private blockchain and I have, let's say, just 2 miners, it means that somebody with free graphic cards can basically trick with some transaction on my private chain, yeah? Or
if somebody else can put something on your private chain or kidnap it from your. Yep. They can put something on your miner to be mined. That is okay. So the question really is like, yeah, what if somebody just puts something, basically participates in my network and then puts something just on my miner, and my miner will start doing all the work, you know, and it's cheap. It's relatively cheap on my machine, so they will just do that. That is, of course, possible if they know how to access your network. So they need to know where to reach it. So what's the address, and that also then depends on if you want to prevent that, for sure put the no discover on in your configuration so that your network is not just discoverable by somebody, and then so you can do a couple of things to make it harder. Yeah. And you can also, for example, you can also configure how many peers you allow in your network. So, for example, if you know you consented to 3 different nodes or parties to be in your network, you can say, oh, the max peers is 3. So if they are connected, there's no way somebody else can get also can connect, because that would be peer number 4. So there are a couple of ways to control it. So, sorry? Yeah, okay.
provided by limited access to the private network and not by the proof of work.
True. That's true. So the remark is that private network security is mainly done by limiting access to that private network. So that was the remark there. Okay, any other questions at this point? So I guess we will make sure that you get some of the how-tos if you want that, and you know how to find us, I guess, if you run into questions or issues when you are working. Oh yes, that good remark. If you want to create a trial environment on Azure, there are 2 ways to do it. One is just to do it yourself. You can just ask for a free trial on the portal, but it means that you have to use a credit card for identification. It's not being charged, it's free, but it uses it's like a physical identification kind of thing. Or the other way is to come to us and ask for a code. We have some codes, some free pass trial codes, and you can then just register using that code and get and then you would also have free trial. So either way it would work. So you can come if you want to use that free trial pass and ask it. Okay, so thank you.